Yosemite. Today we're out at Super Slide here in Yosemite Valley looking for monkeyflowers. I'm a PhD student at Tulane University and I study adaptation in Mimulus laciniatus. And Mimulus laciniatus, one of the monkeyflowers, loves to grow on south-facing slopes. So it loves the full morning sun and lots of water and moss. So as you can see here, we're next to a seep on a south-facing slope, and we've got monkeyflower growing high up there in the cracks. So we're looking for populations all over the rocks to see how it has adapted to this very harsh habitat of vertical faces and tiny cracks and very short water supply. So join us on our adventure up Super Slide to find some more plants.
The most immediate goal is to see if the monkeyflowers in this species that are growing at these different heights, if they're actually differentiated, if the way you would expect other populations within the species range to be different from each other. Do we see the same genetic differences in these monkeyflower populations that we would expect if they were miles from each other? For this species, the cut-leaf monkeyflower, it inhabits a very distinct and different environment, very unique in the world, I would say, this sort of extreme cliff face environment and a south-facing hot environment. So it's a really nice system to understand how plants may adapt to extreme environments and what that process looks like. Also, this species of monkeyflower and many species of monkeyflower are very easy to grow. So it's very easy for us to take seeds, grow them in the greenhouse or growth chamber, go through a generation within only a few months, and compare individuals from different places and do lots of experiments. We can pollinate different monkeyflowers with each other, see what the effects of that experimental gene flow might be. So it's really easy to work with. And then there are a lot of molecular tools that are easy to apply. So we ultimately understand what genes are involved with different adaptations in this species or other monkeyflower species. So it allows us from top to bottom to understand sort of from the ecology all the way down to the genetics and the genes that ultimately define what our traits are like. But that's my first goal, is to understand how plants can inhabit such a large face that crosses such a massive climate boundary or gradient. Do they do it through adaptation, or are they just able to live on any part of that wall? And usually we call that plasticity of something, if individuals can live in many environments versus they have to be adapted to certain environments to have a wide distribution.
So we're out here on the last pitch's Super Slide, about 500 feet off the ground, and we see here in this moss, right on the root, we've got some monkeyflower growing. Some of it has already bloomed and set seed, and we've got one little last flower getting ready to pop out right there. We're next to this seep, a little cave where water is coming out, and there's some thick moss, and I think I see some more monkeyflower up in there. Just growing out here in its natural habitat. Full sun, lots of moisture. Feel nervous with everyone watching me go. Oh, look at me. Psyched. First monkeyflower.
4, 5, 7 5s and 1s.
I ended up with so many lockers.
And I'm using that.
Oh yeah. Those are there too.